Okay, now let's look at the external genitalia. Okay, so this would be sexual differentiation in humans, but now we're looking at those external structures. So we need to give a couple of names here, right? Again, we're already comfortable with the fact that everybody looks about the same internally and externally at 7 weeks. So what does the anatomy look like? Well, we have a genital tubercle. That's going to either become the glands of the penis or the glands of the clitoris. Have some urogenital folds. Those are marked in red there. Those are going to create that external structure that becomes the urethra, and then they'll also create the labia minora in females. We'll see what happens a little bit differently in males. And then finally we have labioscrotal folds. Those are either going to become labia or the scrotum in the male structures. And we can look at this electron micrograph of an actual developing embryo, and we can see all of those things really clearly. Right? Genital tubercle, urogenital folds, we can see the system is completely open at that point, right? And we can see these larger labioscrotal folds. A lot of these changes in development are dependent upon testosterone or the lack thereof, and more specifically dihydrotestosterone. That's going to be something we'll talk about a little bit more at the end of the lecture, because we can get some of these structures to form partially one way or the other. Excuse me. All right, now let's move forward in time. Let's look at about 10 to 12 weeks and see what we have as far as external differentiation. And we're starting to see structures that are gonna look a little bit more male or female. Okay, so these top two images, along with the third one, the cartoon, those are going to be the structures developing more female. Okay, so we can see the genital tubercle is still pretty large in this figure, in these images, as well as the figure. So that's a very big clitoris. So it needs to shrink up a little bit. Remember, there are internal structures, but as far as what we're seeing as the glands, that's going to get a lot smaller. Okay, the labioscrotal folds, we can see those structures out there. Right, they're going to remain open. Those structures will still be there. And as far as the internal, not internal, but internal to the urogenital folds, we'll see the urethral orifice will start to form. Right, that's going to be independent of the hymen and the vagina. Right, those structures are going to stay separate. Now, what ends up being really interesting is the male. Those structures really kind of knit together. And so here in the male system, we can see, right, our genital tubercle. But what's happening here, right, we can still see a bit of an opening, but those structures at the base, they're starting to knit together. So what happens is at the base there of the penis, those urogenital folds are going to start to come together and enclose the urethra. So what's left here in this image is just a little bit of a urethral groove, which is going to be completely covered up by penile tissue, and then we won't be able to see that whenever we finally get to 16, 20 weeks. Okay, so we're looking at a slightly different view there, and we can see the glands. We can see the scrotum has really come together. You can see the line, the raph up there. We don't have a great view underneath of our genital tubercle, but what should be happening again is that urethral orifice is now going to come out the tip of the penis because all of those structures have come together. What happens if they don't? Okay, so there are some really common defects in formation of that penis, most specifically the coming together and wrapping of the urethra inside the penis. So it's called hypospadia. Anything hypo means low or under. So this is referring to that external urethral orifice, and it might be coming out not at the tip of the penis, at the glands, but at a lower portion along the shaft. So it's going to be on the underside. So we can look at this image, and these blue dots are indicating varying degrees of hypospadia, where the urethral orifice comes out along the length of the shaft, or even as low as the scrotum, if the urethral orifice doesn't get connected by those tissues. And so that can be concerning. There are some other things that don't happen very often, not as often as hypospadia, but there could be penile agiensis. If the genital tubercle never forms, you can't make a penis. The bifid penis, this is if you end up with two genital tubercles, you could actually end up with two penises. I'll leave you to do your own internet searching to see that. There is a man who is making a lot of money advertising that. And then micropenis. This could either be described as underdevelopment due to a pituitary defect. We're going to get into, it's not just about testosterone, but there are signals that need to be sent back and forth from the brain and the testes to control development. Or we'll talk about intersex, when people are kind of in between. Right? So is it a micropenis or is it a really big clitoris? There are some things that can happen during development that make it ambiguous as to what the sex of the individual is, and then that can lead to an interesting discussion on gender as well. So again, I'm going to make sure that everyone has their book and they should be reading through these. What we've covered so far as to sexual differentiation is we've really talked about the indifferent fetal sex, that bipotential gonad, and we've gone on to the next layer of this, the differentiated fetal gonad. But what we really need to do is back up and talk about chromosomal sex. Because even though we do have this bipotential gonad, it doesn't make a decision until 8 weeks. We do have chromosomes that are determined at the moment of conception, the moment that egg is fertilized by that sperm cell. So we need to back up and talk a little bit about chromosomal sex. And what I would like you to do before you watch my next video is to watch the sex determination video on online. So it's on YouTube. There's a link to the TED Talk there. And it's really well done. It doesn't just talk about humans, but it gives us some context for some variety between how reptiles are developed, temperature dependent, how birds have a different chromosome system. There's even more creative systems that are in ants and hive insects and things like that. So we're going to broaden our scope a little bit, and there absolutely will be some questions on the quiz and the exam about not just how humans determine sex with X and Y chromosomes, but how other animals do it with a larger variety.